Okay, question 9. A regular polygon has interior angles of 150 degrees. How many sides does this polygon have? The fact it says regular, okay, means all the interior angles are equal, okay? And all the sides are also equal in length. And it's saying, look, you know, if I was to do a rough sketch of this, okay, just a rough sketch, that would be 150 degrees, every interior angle. Now it says how many sides. There's no way you can work out, right, how many sides it's got just by looking at the interior angle. There's no way of doing it. But what you can do is work out what the exterior angle is, right, with polygons. Now the exterior angle you get when you continue the side, if that continues here, so I've done it broken to show you if it continued along, if you've got this angle here. And of course the exterior angle is easy to work out, isn't it? When you look at that there, the exterior angle is simply, you know, because that's a straight line, you just got to do 180 degrees, haven't you, in a straight line, and you just take away the interior angle, okay? And you don't have to write this formula down, but it's just for you to see how it works. So basically, that would be 180, take away 150, so you can see now the exterior angle is 30 degrees, yeah? Okay. Now we know the exterior angle. This is good because every polygon, right, doesn't matter how many sides it's got, okay, it could have 30, 40 sides, it could have 6 sides, right, it doesn't matter. The exterior angles of any polygon will always add up to 360 degrees, okay, always, right, it doesn't matter how many sides it's got. As I said, when you sum the exterior angles, they'll always add up to 360. Now, of course, that's not true for the interior angles. The interior angles will sum differently depending on how many sides. But regardless of how many sides, the exterior, the sum of them will always add up to 360. And what's great here, because it's a regular polygon, all the interior angles are the same. They're all 150. All the exterior angles will be 30. So every exterior angle will be 30. So we just got to think, right, well, how many 30s are there going to be? Okay. How many 30s are there going to be? And we know it adds up to 360. So what we can do is 30 degrees, right? We're going to multiply that, right? Because we want to know how many are there by the number of exterior angles. Okay, so I don't know what this is, so I want to work it out. 30 degrees times the number of exterior angles, that's got to give me 360 degrees. It always has to. So then when you've got this, you can work out how many exterior angles there are. So of course, because you times and you can take it over and divide. Those zeros cancel. 36 divided by 3 is 12. Okay, so there's 12 exterior angles, and if you've got 12 exterior angles, you've got 12 interior angles. You also got 12 sides. Okay. Now part B, it says each side of this regular polygon is 6.5 centimeters. A sketch of two sides AB and BC of the polygon is shown below. Using only a ruler and a pair of compasses, construct an accurate drawing that shows these two sides of the polygon. Point A has been given. You must show your construction arcs. Now, 150 degree angle is going to be quite hard to construct, right? It's not something that we learn, but 30 degrees, that's what that is there, isn't it? And 30 degrees is doable. So what we do is, we get our ruler, okay, and we first of all going to draw out AB, okay, AB. Now we know AB is 6.5 centimeters, okay, because it says in the question. So I'm going to measure that out and then go to 6.5 here, right? And what I'm going to do as well, I'm going to do a little bit of dotted lines as well, just so it sort of help me, okay, just a bit extra, just so you have that exterior part there. Okay, now I can call this B. So what I'm going to do now, if I can get a 30 degree angle, right, I can then do BC. So all I'm going to do then is get my compass, open it up a certain amount, right? So put it on B, right? Open up a certain amount so that it sort of is on that, is going to cross those dotted lines. So that's just fine there, right? What I've got there. What you do then is from B, you do a quarter circle, right? You do a quarter circle. Okay, or just over a quarter, that's fine, right? Quarter circle's fine. And then where that arc you just drawn in, you don't change this, right? The gap here, you keep this the same, but you put your pin then here where that arc crossed that line. and you draw an arc here, right? Now that then, if I drew a line through here, that would represent 60 degrees, right? If I drew a line from B to here, that would be 60 degrees. That's how you do a 60-degree angle. But I don't want 60, I want 30. Okay, I want 30. So what you do then is, if I know that's 60, to get 30, I just got to bisect, haven't I? Because 30 is half of 60. So you bisect. Now when you bisect an angle, you need this arc here, which has already been drawn for us. And then what you do then is you put your pin back here, okay, on here, and you draw an arc over here, okay, and then you put your pin then where these arcs cross. You draw an arc then, so that these arcs actually cross. Okay, and then the last step then is you get your ruler and you line this up here, B, to where those arcs cross. Okay, and then you draw through, if it's possible, to draw through those arcs. So they lined up to 6.5. And as it says, don't rub out your construction arcs. We can label that then C, right? And we've got then this then in here, because this is 30, this is going to be 150.